Alright, ladies and gentlemen, I'm sure you missed me, but I'm back. So I promised I would do a little review of your quiz, so here we go. I'm not going to go over every single problem because I just don't have the YouTube time to do it, but I'm going to point out a couple of ones that I know you had questions about. The first one appeared on the first page. It was number 7. In fact, I got a note from Miss Wong saying that a lot of you thought that the answer wasn't there, that I did it wrong, or the question didn't make sense, but in fact it does. If you want to find out the probability that you select two Skittles and they're the same color, you have to consider this statement that I have down here at the bottom of the page, which is the probability of getting red and red, or green and green, or purple and purple, or orange and orange, or yellow and yellow. And because you're told that you're allowed to assume that they're independent in the problem, you can just do 0.3 times 0.3, 0.3 times 0.3, 0.2 times 0.2, 0.1 times 0.1, and 0.1 times 0.1, and add up those probabilities, which add up to 0.24. So that is the correct answer in B. So no, it was not wrong. It is there correctly. On the second page, I was actually kind of surprised at the number of errors that were made on page 2 of the multiple choice. So given the probability distribution at the top, you just had to determine whether or not any of them could be a valid probability model for flipping and recording the number of heads. Now, it didn't say that it was a fair coin. Simply the probability model must show all possible outcomes and lead to adding up to 1. So you'll see in the first one, a third, and a third do in fact equal 1. That is correct. The second one, though, 0.75 does not equal 1, and in the third one, you're greater than 1. So the first one is the only one that is a valid probability model. I think probably where people got thrown off was they wanted it to be the exact model for flipping two fair coins, or for flipping a fair coin twice. This could be a probability model, though. It could be that it comes out 1/3, 1/3, 1/3. As you move your way down through the remaining problems about childbirth, again, 10 and 11 were a little bit shocking to me that people would get these wrong. So what I've done is in 10 and 11, I drew out the sample spaces for you. So in 10, this is your sample space of boy, 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 girl, girl, boy, and girl, girl. And the question is asking you, what's the probability that the next two babies are of the same sex? Well, that means that they could be two girls or two boys. And again, the or statement being the sum. So there's a 1 in 4 chance that they're two girls. There's a 1 in 4 chance that they're two boys. There is no intersection of girl, girl, and boy, boy, so I don't have to worry about subtracting it off. So a fourth and a fourth is a half. Half of the outcomes in the sample space, 2 of the 4, are babies of the same sex. In number 3, now you're talking about 3 babies. So I attempted to start to make the sample space for you, but I stopped because we know that there's an easy way to do this problem. There are 8 possible outcomes with two sexes, 3 kids. So boy, 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 girl, boy, boy, girl, girl, boy, girl, girl. Yeah, there's 8 of them, all the way up to girl, girl, girl. The question is that you want to find the probability of at least one of the next 3 is a girl. Well, there's only one outcome that has no girls, which is boy, boy, boy. So this should just be the complement of the probability of boy, 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 which is 1 out of 8, which is 0.125. So 1 minus 0.125 is 0.875. So those were a couple of the ones that were missed on that page. All right, this particular problem, I know that I said it in class a million times. Being able to write down the probability statement will lead you to being able to get the correct answer. So in this one, you're talking about winning one of the contracts, but not winning both of them. So we're really looking for the probability of winning contract A or contract B, but we can't win contracts A and B at the same time. So we're looking at the probability of A or B minus the probability of A and B. Well, the probability of A or B is P of A plus P of B minus P of A and B, and then the additional minus the P of A and B at the end. So you're taking the probability you win A plus the probability you win B, subtracting the overlap so you don't count it twice, and then actually pulling the overlap out again. So basically you're left with this diagram in letter C, where you could win A, you could win B, but you can't win both. For the next problem, most people did a decent job. Actually, I think everyone did a decent job setting up the tree diagram to be able to answer this particular question, but then fell a little short on answering some of the probability statements. So I really tried to help you guys out, not only with using your notes, but also giving you the probability statements. So you'll see in part B, probability of senior and easy. So senior and easy, since these are independent events, would just be the probability of senior times the probability of easy, which is 0.103. And let's not even bring up the fact that, once again, you were supposed to round to the nearest thousandth. I overlooked that because I wasn't there to remind you, even though it was in big bold letters above. C, what's the probability that a randomly selected student thought it was easy? So the probability of something being easy was senior and easy or junior and easy. So add those two together. That gives you the 0.267. And then the conditional, the probability of easy given senior is probability of easy intersect senior divided by probability of senior. I saw a lot of people here with probability of easy in the denominator. That shouldn't have happened because, again, you had the formula in front of you. So that just is your answer to part B, divided by the probability that you were a senior, 0.47, 0.219 is the answer. Another commonly missed thing on this page was in 18A that 7% is 0.07, not 0.70. And there were a few of you that tried to give me the 52 here as well as the 7 here, which doesn't make any sense with this particular Venn diagram. All right, on this page, you can just take a look, pause it if you need to, and look at how to go about doing it. I had a lot of people in B forgetting to subtract off the probability of statistics and computer. So you had an answer of I don't even know what it was, 0.80, 0.75 maybe, but it's 0.68. Then in C, the probability of the two complements is 1 minus the probability of it being easy. So just 1 minus the probability of taking either of them, which is 1 minus 0.68, which was the one above. So 0.32. I think these are all pretty explanatory. Again, when people got down to the conditional, again, some of you divided by probability of computer instead of probability of statistics. G, are the courses disjoint? No, they are not. They're not disjoint because they have an intersection. Whenever you have an intersection, you're not disjoint. The intersection, in fact, was 7% of the time. So, no. I mean, you could have looked back at the previous page. Clearly, the Venn diagram intersected. For number 19A, yes, filled in that. You guys did a good job. B, so I ended up not counting B because I saw what a lot of you were doing. I gave you the probability statement that I wanted. I wanted the probability of Spanish and chemistry. Most of you read this as a conditional, though, even though I didn't write it as the conditional. So you gave me a conditional answer, and I could see why you did that. So I ended up not counting this one for the 2 points because I could understand how you would want that, but you didn't look at what I was asking you to do. So the probability of Spanish and chemistry is just 35 out of the 136, or 0.26. A lot of you gave me the probability of chemistry given they take Spanish. Okay, and on the last page, a lot of you just put down numbers. It was hard if you got the number wrong to give you any partial credit. So probability of taking Spanish is 102 out of 136. The OR statement, again, is P of P plus P of S minus P of P and S. Quite a few people forgot that subtraction here and gave me the 135 out of 136. And then the conditional intersection at the top divided by probability of F in the denominator gives you the 0.24. For F, really what I was looking for here was a generation of some conditionals and comparing them to just the probability of the individual science subject. So, for example, I did the probability of biology given Spanish. You couldn't generate the probability of science given Spanish. You had to choose a particular science. So this one was for biology, and I wanted to see whether or not these two were equal to each other. So I generated the conditional first, which was 0.43, generated the probability of biology, 0.38, compared these two. Remember, they need to be close enough to each other to say that, yes, in fact, They are independent. These are two different, so no. This shows that they are not independent of each other. You could have chosen any science subject and shown for that. Some people actually did it for every single subject. And then again, based off of what you thought, you could have argued that point 38 and point 43 are close enough together, but you had to make the correct argument given the numbers. If you just gave a written explanation, it wasn't enough on this one. All right, so there's your explanation.